this is my YouTube channel. Today we are going to see how to calculate oxidation number or oxidation state. But first of all, we see what is meant by oxidation state or oxidation number. Oxidation state means the sign of charge or the numerical value on the element. The term oxidation state is derived from the valency, and valency is the combining capacity of an element. So first of all, we see rule to assign the oxidation state or oxidation number. There are several rules to assign the oxidation state or oxidation number of an element, but in which first rule is the oxidation state or oxidation number of uncombined or free element is 0. Means Cl2, Br2, I2, Na, then O2, O3, S8, P4, these all free elements having the 0 oxidation state or oxidation number. Then second rule is the oxidation state or oxidation number of metal is always positive. For example, Na plus, K plus, Ca plus plus, Mg plus plus, Cu plus plus, etc. These all metals having the positive oxidation state. Then third one is the oxidation state or oxidation number of hydrogen is always plus 1 except metal hydride, because in metal hydride the oxidation state of hydrogen is minus 1. Let's see the example. After dissociation of hydrochloric acid, we use H plus and Cl minus ion. Here the hydrogen having plus 1 oxidation state, but in metal hydride the hydrogen having minus 1 oxidation state. Then fourth rule is the oxidation state or oxidation number of non-metal is always negative. For example, O minus minus, Cl minus, I minus, etc. These all are the non-metals and it's having the negative oxidation state. Then the fifth one is the oxidation state or oxidation number of oxygen is always minus 2 except peroxide. In peroxide, the oxidation state of oxygen is minus 1. Let's see the example. In a water molecule, after dissociation of H2O, we use 2H plus O minus minus. Here, the oxidation state of oxygen is minus 2. But in hydrogen peroxide, after dissociation of H2O2, we use H plus and O minus. Here, the oxidation state of oxygen is minus 1. Then, next rule is when two non-metals are combined together and form a compound and the oxidation state of more electronegative element is negative and the oxidation state of less electronegative element is positive. For example, in OF2, we use O plus plus and F minus, and in ClF, we use Cl plus and F minus. Why? Because the electronegativity of fluorine is more than that of chlorine. That's why chlorine carrying positive oxidation state and fluorine carrying negative oxidation state. And in this example, the electronegativity of fluorine is more than oxygen. So that's why oxygen carrying the positive value and fluorine carrying the negative value. Then last rule is the sum of all charges must be 0. So guys, these are the different rules to assign the oxidation state or oxidation number. Let's see the examples. Let's see the first example. First example is hydrochloric acid. And in this example, we have to calculate the oxidation state or oxidation number of hydrogen. So first of all, I write here hydrogen plus. We know that the oxidation number of Cl is minus 1 and the molecules of Cl is 1, so that's why I write here 1, and the oxidation state of Cl is minus 1, so that's why I write here minus 1. Then I calculate H plus minus minus and 1 into 1, 1. When this minus 1 becomes plus 1 when it go beyond the equal sign. So that's why the oxidation state of hydrogen in hydrochloric acid is plus 1. This is first example. Then second one is MnCl2. In this example, we have to calculate the oxidation state of magnets. Let's see. Mn, we know that the oxidation state of Cl. Oxidation state of Cl is -1, and how many number of molecules here? There are 2. So that's why I write here the 2, and the oxidation state of Cl is -1. So that's why I write here -1. Then Mn plus minus minus 2 into 1, 2. Then this -2 becomes +2 when it go beyond the equal sign. So that's why the oxidation state of Mn in MnCl2 is +2. Then we see the third example, that is MnOH3. In this example, we have to calculate the oxidation number of Mn. Let's see. I write here Mn plus. We know that the oxidation state of hydroxide, that is -1. We call it hydroxide anion. In this example, how many molecules of OH? There are 3 molecules of OH. So that's why I write here 3. And the oxidation state of one OH is -1. So that's why I write here a -1. Then Mn plus minus minus 3 into 1, 3. And this -3 becomes +3 when it go beyond the equal sign. So that's why the oxidation state of Mn in MnOH3 is +3. Then fourth example is MnO2. In this example, we have to calculate the oxidation state of Mn. So that's why I write here Mn plus. The molecules of oxygen is 2 and the oxidation state of oxygen is -2. So that's why I write here -2. Then Mn plus minus minus 2 into 2, 4. And this 4, this -4 is becomes +4 when he goes beyond the equal sign. So that's why the oxidation state of Mn in MnO2 is +4. Then we see the fifth example, that is KMnO4. In this example, we have to calculate the oxidation state of Mn. So I write here oxidation state of K. How many molecules of K? 1. So that's why I write here 1 into what is the oxidation state of potassium is 1. So that's why I write here 1 plus Mn plus how many molecules of oxygen? 4. And what is the oxidation state of oxygen is -2. -2. So that's why I write here -2. Calculate it. Solid. 1 into 1, 1 plus Mn plus minus minus 4 into 2, 8. This -8 becomes +8 and this +1 becomes -1 when they go beyond the equal sign. So I write here Mn is equal to +8 minus 1 and Mn is equal to 8 minus 1 means 7 means +7. So that's why the oxidation state of Mn in KMnO4 is +7. Then sixth number. Then we see the example number 6, that is HNO3 means nitric acid. In this example, we have to calculate the oxidation number of nitrogen. I write here the oxidation number of hydrogen. The molecule of hydrogen is 1 and the oxidation state of hydrogen is 1. So that's why I write here 1 into 1 plus N plus number of molecules. Number of how many molecules of oxygen? 3. So that's why I write here 3. And what is the oxidation state of oxygen is -2. So that's why I write here -2. 1 into 1, 1 plus N plus minus minus 3 into 2 6. So I write here 6, and after minus 6 becomes plus 6, and this plus 1 becomes minus 1 when they go beyond the equal sign. So I write here plus 6 minus 1 means 6 minus 1 plus 5. So the oxidation state of nitrogen in nitric acid is plus 5. These are the different examples. Next example, example number 7, K2Cr2O7. In this example, how many molecules of potassium? 2. So that's why I write here 2. And what is the oxidation state of potassium is plus 1. So that's why I write here 1. Means plus 1. Okay. Plus, how many molecules of chromium? 2. So that's why I write here 2. And we have to calculate Cr. So that's why I write here as it is Cr. Plus, how many molecules of oxygen? 7. So I write here 7. And what is the oxidation state of oxygen? Minus 2. So that's why I write here minus 2. Then calculate 2 into 1, 2 plus 2 Cr plus minus minus 7 into 2, 14. Then we know that the minus 14 becomes plus 14, and this plus 2 becomes minus 2 when they go beyond the equal sign. So I write here plus 14 minus 2. Cr is equal to 14 minus 2, 12. The number in multiplication is go beyond the equal sign into division. So that's why I write here 2 in division state. Okay. So 2 ones are 2 and 2 6 are 12. So that's why Cr is equal to 6 means plus 6. So the oxidation state of Cr is plus 6 in. So in this example, we have to calculate the oxidation state of sulfur. First of all, we see how many molecules of sodium? 2. So that's why I write here 2. And what is the oxidation state of sodium? Is plus 1. So that's why I write here 1 plus. How many molecules of S? It's 2. So that's why I write here 2. And we have to calculate the oxidation state of S. So that's why I write here as it is S. Then plus, how many molecules of oxygen? 3. So that's why I write here 3. And oxidation state of oxygen is minus 2. So that's why I write here minus 2. Calculate it. 2 into 1, 2 plus 2s plus minus minus 3 into 2, 6. 2s is equal to, this minus 6 becomes plus 6, and this plus 2 becomes minus 2 when they go beyond the equal sign. So that's why I write here plus 6 minus 2. 2s is equal to 6 minus 2 means 4, and s is equal to 4 divided by 2. 4 divided by 2 means s is equal to 2 ones are 2, 2 twos are 4. So that's why plus 2. Oxidation state of S is plus 2 in sodium thiosulfate means Na2S2O3. Next, example number 9, that is CaOCl2. Okay, we can write this example like this. So let's calculate it. In this example, we have to calculate the oxidation state of Ca. So I write here Ca plus the oxidation state of OCl is minus 1. And how many molecules of OCl? 1. So that's why I write here 1. And oxidation state of OCl is minus 1. So that's why I write here minus 1 plus. How many molecules of Cl? 1. So that's why I write here 1. And what is the oxidation state of Cl? Is minus 1. So that's why I write here minus 1. So Ca, when this minus 1 and minus minus 1 becomes plus 1 when they go beyond the equal sign. So that's why I write here Ca is equal to plus 1 plus 1. Okay. So Ca is equal to plus 2. So in this example, the oxidation state of Ca is plus 2. Example number 10. HClO. In this example, we have to calculate the oxidation state of Cl. We know that the oxidation state of hydrogen is 1, and how many molecules? 1. So that's why I write here 1. And the oxidation state of hydrogen is plus 1, so that's why I write here 1 plus Cl plus how many molecules of oxygen? 1. And oxidation state of oxygen is minus 2, so that's why I write here minus 2. Then solid 1 into 1, 1 plus Cl plus minus 1 into 2, 2. Then Cl equal to, this minus 2 becomes plus 2 and this plus 2 becomes minus 2 when they go beyond the equal sign. So that's why I write here plus 2 minus 1. Then Cl is equal to 2 minus 1 plus 1. So that's why the oxidation state of Cl in HClO is plus 1. Guys, these are the different examples that we see